Hi everyone. Hi Lohita. Hi Anbu. Good morning. Okay, so we still have some time, and I see we only have like 10 learners, so let's just wait for some time. So, whoever has joined, right? Did you guys try to solve the assignment that I gave yesterday? And also all the assignments that I have given in the last, I think, 3, 4 classes? Did you guys at least try to solve it? And are you guys able to get the solution for that? Anyone? I tried till the with clause. Okay. Okay, fine. And what about so yesterday I mentioned about this PostgreSQL course, right, which is free until the end of this month. Did anyone try to like start using that course? Anyone here? Okay. So did you go through the exercises, yoga? Did you any feedback that you have? Like, is it good? Okay, so Pallavi and Yoga have used it. Hi, Tim. Did go through and select and group by. Okay, okay, fine, fine. So I think that's going to have some pretty good exercises, especially for you guys because you have learned SQL from scratch now, right? Now you need to practice more and more. The more you practice, the better you get. And I think that course has pretty good exercises using which you can practice all the skills that you have already learned in this course. They seem very simple. Yeah, they are starting from basic. Okay. So it will just make you more comfortable with joins, subqueries, group by, aggregations, etc. Can you repeat one time? I joined little late. Uh, so you can watch the recording yesterday, Anbu. There is just one course in learnsql.com. Okay. They have some special offer going on currently that they're giving that particular course for free. Okay. Generally, all of their courses are not that they're not that cheap. Generally, any single course would cost, I think, around $30, and the entire platform costs, I think, around $170. But this particular course, they're giving it for free, and actually, it's a very good course. It's not like some useless course. It's a course I think which has pretty good review and it has good content. So they're giving it for free only for the next 20 days. So until September. So I think anyone who wants to utilize and practice SQL definitely should go ahead and use that course. It's just like it's not like teaching course. It's you have some I think 88 exercises. You just need to solve the exercises, and that should probably give you the important information about solving SQL queries and etc. Okay, this seems very simple. I registered. Can you repeat one time? Need to see level of difficulty for the test. Definitely, I look forward to using. Okay, great. What do you think of datawithdanny.com? I just found out about it today from a Telegram group. Okay, so this data with Danny, right? Even I found out about this, I think, during the beginning of this course. Um, I think it was Ahmad. Okay, so I think we have one learner here. I'm not sure if he's present in this class. We have Ahmad, and he had actually messaged me in LinkedIn. He shared me. So I think this data with Danny. I think he has some 8 different. What is that? SQL. I don't know what you call that, but he has some case studies, right? So he has some 8 different case studies, and Ahmad has shared with me and asked me to do one of the case studies in this particular course. But then the problem is this case study and the course content, everything is owned by Danny, right? I do not want to be using the content of some other creator, right? Because if I'm going to be using it, I need to take his consent first. So I have not contacted him to take his consent. But I think the case studies I just went through that, and I think it is pretty good. Okay, so is it free or do you need to pay for that? Does anyone know? I think cases are available outside. Okay, so so it's basically okay. So I think I'm not really sure. Maybe I can check. Okay, if you have the case status ready and you don't need to pay anything for that, I think definitely you should do it. And I'll tell you one thing. Okay, this is what I do every time, and I'm sure this is applicable for anyone. Okay, so when I was learning Python a few years back, okay, there are some of my so I had some favorite resources from where I learned Python. Of course, my absolute favorite was the book Automate Boring Stuff with Python. I think most of the stuff I learned from that book. But since I was a beginner, certain things I would not understand. Okay, when I was getting started. So what my trick was always that I used to learn concepts from multiple different resources. So there were certain YouTube channels like uh, Corey Schaefer, okay, and then there was Tech with Tim, okay, and then there were I think a couple of other Code Basics, and then there were yeah a couple of other YouTubers, Telugu I have watched for some videos, etc. etc. Okay, so for certain concepts I used to refer to certain resources. Of course, I used to have one main resource that was my book, okay. But other than that, sometimes when the concepts were not very clear, I would go through other resources and I would learn there. And in different resources, right, the same concept may be explained in slightly different manner. As a learner, we always need to understand multiple different scenarios so we can then know which actually suits best for us, right? So for me, when I'm learning something, actually a few years back it was Python, today I'm learning some other technology, I always refer multiple resources. Okay, it's not like I purchase courses. Okay, so I purchase a course and it's not like I'm going to be only using this particular course to learn everything. Okay, it's not a bad idea, but if I want to get in depth and if I want to know more ideas, I always refer to multiple resources. So if you're learning SQL from this course, I would also recommend, I see in Telegram group there is a book that Tim has suggested from what is that, I forgot the book name. Okay, so if you want, you can refer to that book, the this data with Danny, the the case studies looks like they are actually pretty good. You can use that. Of course, there are many other YouTube videos and other. So learnsql.com, the free course that I'm recommending, you can take up that. So learn these concepts from multiple different resources will only help you to get even better. Okay, so I do that. I'm sure I know many of my friends and colleagues also do that. So uh, you guys also should definitely refer to that. Okay. Um, I have sent you my email and phone. Okay, Benjamin, I have not received any email. At least till last night, I did not receive. Today, I have not checked my email yet. Maybe I'll check later. Are you going to dissolve Telegram group? No, the Telegram group can stay as long as you want it. Okay, because I see a lot of you guys are helping each other. So and you guys can share in good resources that you have come across learning SQL or any other technology if you are interested. Okay, so the Telegram group can stay. It's like a library of book. You always learn something new from. Yes, right. Okay, even when I'm watching a YouTube video, even for a concept that I know, sometimes someone might explain the same concept in a different way, and that might give me a different idea about a particular topic. Okay. Select star from the team name from teams, cross join teams B. How can I filter multiple records? Distinct is not working here. Okay, so Banumati, you keep. Okay, so 1 minute. Let me copy your question. Okay, I'll just store it. I have a file that I have created for all the unanswered questions. So this is from Banumati. If possible, I'll look at this question at the end of this class, or maybe the one extra session that I'll be having to clarify the Q&A session. In that, I'll answer it. Okay. Okay, so I think we are 1 minute past our. Okay, sorry, 6 minutes past our start time. So let's start. I'm going to share my screen. Okay, so let me know once you're able to see my screen. Okay. You guys are able to see my screen, right, everyone? So I hope you can see it. Okay. So today, let's start with recursive SQL queries. I'll try to cover this one. Okay. Now, does anyone know what is recursive SQL query? You don't need to give me a definition, but when you hear about recursive SQL, what do you think it might be? Any idea? Just by the name, what do you think it might be? This is a very important concept, okay, in SQL. It's part of the more complex concepts, okay. But generally, if you're going for an interview with 3+ years of experience, or let's say even if you're a fresher and you go for a job, okay, you might come across recursive SQL queries in your project, okay. Even though you may not be able to write it on your own, you should at least know how to read it, right? Because reading recursive SQL queries are not as straightforward as reading any other normal SQL queries. Okay, so let's see who can answer that. So Anbu says repeating, Murali says looping query, Adam says a SQL query that calls on itself. Okay, a query that references itself. Okay, kind of CTE, repeating queries, looping query until a condition is satisfied. Okay, fine. Looping inside a query to build parent-child relationship. Okay, uh, okay, fine. So I think most of your guys thinking is correct. Okay, so the name itself is pretty clear, right? What does recursion do? Recursion means it's like repeating something, right? Recursively execute something, right? Or do something again and again, right? Something like that. Okay, now generally what recursive SQL queries means is sometimes we might have a requirement where we might need to process the data in one of our tables multiple times until we satisfy a certain condition. Okay, and the most common use of recursive SQL query is to find hierarchical data. Okay, so when I say hierarchical data, it might be employee manager relationship, okay, or any parent child relationship. Whenever you want to find, we generally use recursive SQL queries. Okay, and this is supported in all the major RDBMS. Okay, so let's uh, before I can show you some examples, I'll tell you what is the syntax of using a recursive SQL query. Like what I explained previously about pivot tables, right? Or the cross-tab tables, there is a syntax that you need to follow, right? Similarly, for recursive SQL query as well, there is a syntax that you need to follow. Okay, so generally we use recursion using a CTE table. Okay, that is using a with clause. So the syntax is something like this. Okay, so we use a with clause. Okay, after the with clause we need to provide a keyword called as recursive. Okay, now this keyword is only required for PostgreSQL and for MySQL. When it comes to Microsoft SQL Server and Oracle, they don't need this keyword. Okay, but I'll tell you the difference in the syntax in other databases a little later. For now, let's start with PostgreSQL. Okay, so I need to say this keyword. Okay, and then I need to give any name for my with clause. So let's say I'm just going to call it like CTE. Okay, and then the normal as clause. Okay, and then here I need to do few things. Okay, so here basically I need to have two queries. Okay, so the first query is the base query. Okay, so this is something like it's like um, I would say the starting point. Okay, the starting point. Okay, so when your query gets executed, first whatever you have mentioned here, this will get executed. Okay, and after you mention your base query, you need to have either union. Okay, or you can also have union all. Okay, you can union or union all, any one. Okay, you need to mention in PostgreSQL. Okay, and then here comes the next query, that is the recursive part of the query. Okay, which uses the result from CTE. Okay, now what this means is this base query is basically your normal query. Okay, where which should return some data, and that query will be executed first. Okay, and then you need to have a recursive part of the query. Here one of the table, you can use multiple tables here, you can have joins and everything, but one of the tables has to be this CTE table. Okay, so and I'll explain you why. So This is what you need to have here, the second part. Okay, and finally you need to have your main part of the query, that is select star from CTE. Okay, so this is actually the syntax of how to write a recursive SQL query. Okay, how SQL is going to process this query is different from how your normal CTE would get executed. Okay. When I was explaining you the normal CTE, what I told you was whatever you mentioned in your with clause, that query gets executed first, and the data, the result set of that query will be stored somewhere in the memory, and you can refer to that result set using whatever name that you have given for your with clause, right? And then you can use this with clause, this table name, anywhere in your main query here, along with many other tables to process, right? So first your with clause gets executed once, okay, only once this will get executed, and then your main query gets executed, okay. But when it comes to recursive SQL query, the thing is, inside your with clause itself, you have two different queries, okay. They are separated by this union or union all clause, okay. So what happens is, recursion is repeatedly execute the query until a certain condition is met, okay. Now here there is one more thing, okay. uh, Here, this include a termination condition. Okay, so this one also, this termination condition also should be part of this second query here. Okay, now base query is basically the data with which your recursion should start. Okay, once, so this query basically will get executed multiple times. Okay, so that is how, because when you execute this query, SQL sees that okay, this is a recursive CTE. Okay, so as soon as you tell that this is a recursive CTE, SQL will expect you to have two queries. Okay, first a base query, then the second is a recursive part of the query. So in the first iteration, okay, in the first iteration, the base query gets executed. Okay, once this is executed, whatever data is returned from your base query will be passed to the second iteration. Okay, so when the second iteration comes, this query will not get executed. Only the query that you have executed here will get executed. Okay, in this case, whatever I told you that one of the tables that you need to use here is this CTE table. Okay, so this CTE table will have the output from the previous iteration. Okay, so in the first iteration, this gets executed. In the second, in the after the first iteration, okay, if let's say if your query is going to have 10 different iterations, okay, so for the first iteration this gets executed, remaining 9 iteration, only this part of the query will get executed. The base query executes only once. Okay, and after each iteration, whatever data is returned, it will be stored in this CTE. Okay, so in the second iteration, the output of the first iteration can be referred by using this CTE. When you go to the third iteration, the output of the second iteration can be used by using this CTE. When you go to the fourth iteration, the output of the third iteration can be referred by using this CTE, and so on and so forth. Okay, until the query will keep on executing until a termination condition is met. Okay, so this is the overall picture of how recursion happens. Okay, I'm not sure how much you understood this. uh, okay, but let's understand this with some example. Okay, so let me take an example now so that you will better understand this. Okay, um, okay, so let's take this query. Let's say I have a problem like this, and this can be a problem that can be asked during interviews. Okay, to be frank, I would definitely ask this problem if I was taking an interview. Maybe not for a fresher, but maybe if someone is 3 years of experience. Okay, so my question tells display the numbers 1 to 10 without using any inbuilt functions. Okay, now when it comes to PostgreSQL and maybe some other RDBMS, there are actually inbuilt functions where you can like display multiple values. Okay, I think generate series is what you can use in PostgreSQL. I'm not sure about other RDBMS if you have some functions. But let's say you have been asked a question where you want to display 1 to 10 without using any inbuilt functions. Now, let's say if you're using Java or Python, very simple, right? You just create a loop, okay, and you iterate the loop from 1 up to 10, okay, and then you just print the value that whatever that is written from the loop, right? You just by using a simple loop statement, you can display 1 to 10, okay, and here I'm telling 1 to 10, it can be anything else, okay. Uh, Okay, so any real-time example which can't be solved using recursion, I will come to that example next. Okay, first let's look at a basic example to understand the concept. Then let's go to a more realistic example that we use in our project. Okay, so now you have a requirement, you need to display 1 to 10 without using inbuilt functions. Okay, so when you have this kind of a requirement where so I need to first display 1. Okay, then I need to increment the number plus 1 and then display that, then I need to increment the number again plus 1, then display that, and so on and so forth. So looks like recursively I need to print the number, okay, 1 2 3 4, and in each recursion I just need to add plus 1 to the previous value, right? So this kind of looks like a problem that can be easily solved by using recursion, right? So let's try to solve this. Okay, again, in order to start a recursive SQL query, my syntax is with recursive CTE. Okay, here I'll give my the two queries, base query and recursive query, and here I'll have my outer query. Select star from CTE. Okay, let me maybe zoom this. Okay. Now here, first of all, what is my base query? Can anyone guess me? Because now you have understood the syntax of recursion, and I told you what is base query. For this particular requirement, can anyone tell me what should be my base query here? Select one as row number. Correct. So Brent is correct. My base query can just be a query that is going to return one, right? Because what is base query? There should be some starting point so that using that SQL can then do the recursion, right? In this particular requirement, my starting point has to be one, right? I need to first display one, and then from there I just increment one at a time so that I display up to 10, right? So I can tell my base query would be something like just select one, okay, and I can give an alias for this, like let's say num. Okay, so or I'll just call it like n. Okay, so here I don't need to use the from clause because when I run select one as n, I'll just get the value as one. Okay, so this can be my base query. That is fine, right? Next, I need to use my union or union all, whatever. I'll use union here. Okay, and this is basically where I need to provide my recursive part of the query along with my termination condition. Okay, so the first thing is when I'm using recursion, okay, I need to have a query here, and my query needs to use the CTE table, whatever name that I have given here, it needs to be used. Here I missed the as clause. Okay, so this has to be there. Okay, now how can, so in my first iteration one is displayed, I know that. In my second iteration I want it to display two, right? So what I can do is this CTE will, this query will get executed in the second iteration. In the second iteration, this CTE will have the output from the first iteration. My first iteration already returned n equal to 1, right? N is the column name and it has a value 1, right? So what I can do is my CTE table has a column n, okay? And if I just do n plus 1, okay? And let's say if I print this entire thing, okay? So I don't need to put this inside parentheses, but just to make it meaningful, I'll tell n plus 1 is going to be my new n now. Okay, so I can do this. Okay, so in the second iteration, CT is going to have value from the first iteration, that is 1. So 1 plus 1 is 2. So 2 will get printed in the second iteration. Okay, and when it goes to the third iteration, the CT is going to have the output from the second iteration. That is, n would be 2 in that case. So 2 plus 1 is 3. So 3 would get returned. In the fourth iteration, or yeah, in the fourth iteration, the output from the third iteration was 3, right? So n would be 3. 3 plus 1 is 4. So this would get returned 4. Okay, that is fine. But the thing that I'm missing here is I have not added a termination condition. If I do not add a termination condition and if I execute this, this is going to have an infinite loop. Okay, this query will get executed infinite number of times and it's basically going to hang our database. Okay, so always when you're using a recursive SQL query, always make sure that you have a termination condition. So what can be my termination condition here? Can anyone guess? Okay, n less than 10, right? So I can just tell n when it is less than 10, okay? Should it be n less than 10 or should it be n less than 11? Because I want to display from 1 to 10, right? So as soon as n becomes, let's say 9, okay, when n becomes 10, this condition will fail and our entire query will get stop executing, right? Okay, so let's see, okay, whether it should be 10 or some other value. Now let me execute this, and you can see that I am getting some data, and you can see that it is displaying 1 to 10. Okay, so I hope this is clear. And the reason why I am putting here as 10 is because, so initially n is 1 that I got from the base query. In the second iteration, it's displaying, let's say 1 plus 1 is 2. Okay, and then the same thing happens until, let's say, it comes up to the ninth iteration. Okay, in the ninth iteration, n is 9. Okay, 9 plus 1 is 10, so 10 gets displayed. Okay, and then when it comes to the 10th iteration, in this case n is 10, 10 plus 1 is 11. Okay, but here 10 is less than 10, this will fail, so 11 does not get displayed. So only until 10 will get displayed. Okay, so did everyone understood the syntax of recursion and how the processing is happening? Did everyone understood? Okay, if you have understood this, then we'll go into the next problem. Okay, so everyone is clear. Now let's move on to the next problem. So I have, let's move on to a problem that for which we actually use recursion a lot. Okay, uh, whenever, whenever you are, so let's say you are using, you have a requirement to find hierarchical data. Okay, maybe employee manager relationship, or let's say sometimes you are building a UI screen. Okay, where you have a menu, some menu. Okay, so generally what happens is, um, let's say you go to some product. Okay, some product website. Okay, maybe I don't know, maybe Samsung website. Okay, you see they have products. Okay, under products they have, like, let's say TV, and then mobiles, and then tablets, etc. When you click on mobile, it will show you all the different types of mobile. So let's say the Galaxy series, or the A series, the M series phones. And then when you click on the Galaxy series, it will show you the S22 or S23, and then the Note series or whatever, right? So this is like the hierarchical data, right? So here I'm going to show you an example of employee manager relationship, but the same thing can be used when you have hierarchical data. For example, if in a product website, okay, where you have the products, each product might belong to a particular category, and that category might belong to some other parent category, and so on and so forth. Even in that case, if your project is using SQL, they might ask you to write recursive SQL queries to display that kind of hierarchical product. Okay, so um, so for sequence generation also you can use it. Okay, but generally if you want to just generate a sequential number, you have a inbuilt function, or you can use sequence itself. Okay, or sometimes you have some inbuilt functions as well. Okay, so let's look at this problem, but before I look at this problem, I need the data set. Okay, so let me create the data set for this. I'm going to share this data set with all of you. Okay, so create this table, and let me share this data set with all of you. Okay, if you want, you can create this data set, because I'm going to ask you a question once I solve one of the problems, and you will have to do some slight modification to the query to come up with some result. Okay, so maybe you can try to use this data set and create it in your database. Okay, so I'm just going to have this here, and my second question is this one, right? So let me put that question here. Okay, so find the hierarchy of employees under a given manager Asha. Okay, so first of all, let's see what the table data looks like. Select star from employee details. Okay, so I have a table here, employee details, and I have an employee ID, employee name, manager ID, their salary, and their designation. Okay, so these information are present. Okay, now I have a requirement where I have been asked to write a query to find the hierarchy of employees. So the hierarchy of employees under a given manager Asha. Okay, so let's say I have this manager Asha here. Okay, so Asha is an employee, you can see here, and she is a manager. Okay, so she's a CTO. Under her, there might be some other employees, etc. Okay, so what we need to do is we need to find who are the employees under her. Okay, so Asha has an employee ID 7. Okay, and then here if I see employee ID 7, basically this is the manager ID. So looks like Michael and Arvind are two employees who are working under Asha, and I can tell that by using this manager ID here. Okay, and then similarly, Michael is having an employee ID 5, and I can see that Michael again is a manager who has three employees under him. So Satya, Gia, and David. Okay, and then 2, 3, 4. Do I see any 2, 3, 4 here? No. Okay, but then this Arvind 6 here I do not see. Okay, so in other words, I can tell that just by looking at the data here, I can say Asha is having employees Michael and David. Okay, sorry, not Michael and David, Michael and Arvind, okay, under her. And then under Michael, okay, so maybe I'll just, so Asha has Michael and Arvind under, who is working under her, okay. And then again, Michael has, I think, three more employees, right? So Satya, and then Gia, and then David, right? So the hierarchy is something like, uh, under Asha, there is Michael, and Asha also has Arvind working under her. Okay, Michael again is a manager who has three employees under him: Satya, Gia, and David. Okay, and there might be more as well in this particular table. I think only this much hierarchy you have under Asha. Okay, now if I had to write, if I generally have to scroll through data like this, okay, so recursively scroll through the data until I find some relationship between any particular data set. Okay, we generally can do this by using recursive SQL queries. Okay, so I don't think so. You can do this by using normal SQL queries, like maybe using self join and everything. Maybe using self join, you can just find one employee and their manager. Okay. Then again, from so in this particular case, you can find one manager and an employee under them. Okay. But again, if I had to scroll through the data for that employee, again scroll through all the employees under that particular employee, and then the hierarchy might be even more. In that case, I cannot do this by using self join. Okay, here I will definitely need to use recursive SQL query. So let's try to solve this problem using recursion. Okay, so first of all, let me write the syntax for this. So I'll just tell recursive CPE, okay, and as, and here I can just tell, so I need to have my base query, okay. In this case, can anyone tell what can be my base query? Okay, anyone, what can be my base query? Uh, okay, select data from the employee tables. Anyone else? Okay, so Krishna, when he tells select from the table where name equal to Asha. That's right, right? Because as per my requirement, I need to find a hierarchy of employees under a given manager Asha, right? So given manager Asha is basically my starting point, right? I need to start this recursively going through the data starting from Asha, right? So my base query is going to be select star from what is the table name? Employee details, right? So employee details, okay, this one, okay. And let's say I'll just move this to the same line here, okay. And here I need to have my union clause, okay. So this is my base query, that is fine. Now comes my the recursive part of the query, right? So first of all, okay, here I need to have a filter condition telling that where name equal to Asha. Okay, so if I run this, I'll just get one record, that is the data for Asha. Okay, now what I need to do is, once my query gets executed, the base query is executed in the first iteration. So from this base query, I will get the employee ID as 7 and her manager ID as 1. Okay, my intention is, under Asha, under this particular manager, I want to know who are the employees under them. Okay, so I take the employee ID of Asha, okay, and I search for this employee ID in this entire employee details table under the manager ID column. Okay, so if I go into my manager ID column, okay, so Asha's employee ID is 7. If I search for this 7 in this particular column, whatever record matches, those are the employees who are working under Asha. I can tell that, right? So what I can do here is I can just tell select, okay, from employee details. I'll call it like, let's say, E, and I need to join it with my CTE table. Okay, so because my CTE table is going to return the data for Asha, and employee details table is going to have data for all the employees. Okay, and how do I join this? I know that Asha's employee ID is 7. Okay, so I take CTE dot ID, okay, her employee ID, and I try to match her employee ID in the manager ID column of this entire table. This entire table is represented by this employee details table. So here I can just tell E dot manager ID. Okay, so when I do this, probably hopefully this ID will be 7. This 7 will get matched with these two records, so I should get these two records. So in the second iteration I should get these two records. Okay, and then when I go to the third iteration, the the CT is going to have data this one. Okay, only these two records. Okay, because in the previous second iteration these two records were returned, so CT is going to have the IDs 5 and 7. So this 5 and 7 will get matched in the manager ID. So for 5, again these three records will get matched. For 6, there is no manager ID with 6. Okay, so in the third iteration probably these three records will get returned. Okay, and when you go to the fourth iteration, it is going to take the ID from these three employees 2 3 4, but 2 3 4 is not present in this manager ID column, so nothing gets returned. So it will the iteration will get completed by itself. I don't need to add a termination condition here, because as soon as this join fails, the recursion will stop. Okay, so I hope that is clear. Now here I need to fetch all the columns that I want. Okay, so what I'm going to do is I'm just going to say I want to print here like ID. Okay, and I'll say this is like my employee ID. Okay, and then I want to print name. This will be my employee name. Okay, and here also I want to print the manager ID. So manager ID. Okay, and I think that's all for now, should be enough. And I'm going to use the same columns here. Okay, so in this case, I want to print the names from. So I'll match 7 with these two. So I want to print ID. So I'll just tell E dot ID and E dot name and E dot manager ID. Okay. So I think that's all. And one more column that I will add is I want to know in each iteration what were the records that were fetched. Okay. Whenever you have this kind of requirement, we can add a additional column here. That is, I'll just call it like level. Okay. So this one is kind of like I'm hard coding it. Okay, so in the first iteration I'm telling that this is level 1. Okay, when I come to the second iteration here, I will tell level plus 1. Okay, so this level plus 1, this will be my level column. Okay, so in the second iteration this will be 1 plus 1 2. Okay, in the third iteration level will be 2, 2 plus 1 is 3. So for each iteration, what was the data returned, I'll come to know by using this level. Okay, so now let me execute this, and I'm getting an error. So let's try to fix this. ct.id. Okay, okay, ct, it's not ct.id, it is ct.employee id. Okay, so because I have given an alias employee id, right? So this ct is basically the result from my entire this entire ct, right? So if I execute now, now you can see that I think I'm getting the data. So based on using this level, you will come to know in each iteration how many records were fetched and how many iterations have happened. So you can see that I have level 1. In level 1, one record was fetched. Okay, that is basically my base query. And in level 2, two records were fetched. That is Michael and Arvind, who are the employees under Asha. And in level 3, three records were fetched. That is Satya, Jia, and David. And it did not go to the fourth level because when it came to the fourth iteration, this join failed. Okay, so this is how I have found the hierarchy of employees under uh, under a particular manager. Okay, is it clear? Any confusion? What if someone has two managers? If if someone has two managers, so let's look at this table. Okay, so let's take an example. Okay, so let's take uh, even if anyone has two managers, this will still work. But Just let's look at an example. So I have Michael is 7, and let's say if Michael also had another manager, maybe someone else, okay, maybe Shripad, okay. So in that case, what would happen is this Michael's ID is 5. Okay, so let's do one thing. Okay, let's try to add a new record into this table and let's see what happens. So insert into employee details. Maybe I'll add this at the end. Okay, so here, let's see if this works. What was your question? What if someone has two managers? Okay, so I'll just do an insert here, insert into employee details values. Okay, and I have an ID. So for which employee shall I add another manager? So let's say Michael has 7. Okay, maybe I'll add for Arvind. Okay, so I'll say 6. His ID is. But this is a PK, right? I cannot add. This is a primary key, so I cannot have multiple records here. Okay, so in this particular case, the employee ID will differ. Then this query will not work because I am doing all the join based on employee ID, right? In this particular case, I cannot add another employee because here I have the ID as PK. But if you have certain such, you want to test certain things, right? You just try to create this table without PK and then you see how this works. Okay, but I think whatever the hierarchy is, this is going to work. Okay, how can I print the name of the manager instead of just the manager ID? Another solution. What is a term? Okay, so good question from Murali. Okay, now this is actually what I wanted to ask you guys to solve. Okay, I hope everyone has understood this. Now I'm going to give you, let's say, 2 minutes. Okay, and I want to see who can solve this problem to also display the manager name. So what I want is, I'll remove this, okay, because um, cannot do since ID is PK. Okay. My question is, rewrite above query to display only employee ID, employee name, and manager name. Okay, so I want you guys to rewrite the above query and only display these three columns: employee ID, employee name, and manager name. Let's see who can solve this. Okay, I'm going to share this query with you guys here. If you want, you can reuse the query. Okay. Okay, so I will re-explain. But before that, let's see anyone can solve this. Okay. Okay, so maybe I will re-explain now. And until then, if anyone is able to solve this particular problem, then fantastic. Okay, so I'm going to print this problem here. Okay, and I want to know how many people did not understand this part, the recursive concept. Who has not understand? So I see two people already told they did not understand. Adam and I think Shiva previously. Anyone else who did not understand? Okay, Shantanu did not understand. Anyone else? I want to know if a lot of people did not understand or only few. Okay, Dolly, I need re-explanation too. I was a little confusing. Okay, fine. So can you tell me which part is confusing here? Okay, I will explain again, but I just want to know among, because there are few different parts here, among all of these parts, which is not very clear. The recursive part. So you mean this query here is not clear, is it? Okay. Okay, so let's try to explain that. Okay. First of all, I want to ask, did everyone understand what is this base query? Did everyone know why we need a base query? And did you understand what this base query will do? Everyone understands base query? Anyone? Okay. So I hope everyone understands base query, right? Because it is pretty straightforward. You can, in your own words, you can just tell this is the starting point. Okay. So your recursive query execution starts from the base query. And the most important thing is base query will execute only once. Remember that. Okay, base query executes only once. Okay, so once. Okay, so what happens when I execute this query? Internally SQL will come to know this is recursive CT. Okay, since it is a recursive CT, SQL will look at the syntax and it will expect that there should be one query here, another query here, and in between those two, there can either be a union or a union all. Okay, and you have all of that, so the syntax is fine. Okay, so then SQL will go ahead and execute the base query. Okay, and it will execute the base query and it will just move on to the next iteration. Okay, so what is iteration is basically I don't know how to explain iteration. It's basically your query execution is still going on, but your query gets executed multiple times. Each execution is called as one iteration. Okay. So generally, if it is a non-recursive query, your query executes only once. Okay. Whatever it executes once, and whatever output is returned, it will come out. Okay. It will return that output. But in a recursive SQL query, it the execution will happen multiple times based on the termination condition. Okay, in this case your first iteration is basically the execution of your base query. So once the base query is executed, this data will get executed and you will get Asha, the data for Asha, right? So you have got all of this: employee ID, employee name, manager ID, and level. Okay, for Asha. Okay, then the query gets executed one more time. That is called as second iteration. Okay, in the second iteration, only this part of the query will get executed. In fact, after the second iteration, any number of execution, any number of iteration, only the second part gets executed. Base query only gets executed in the first iteration. Okay, now when you come to the second iteration here, okay, let's look at the query. So first of all, I have the employee details table. I know what employee details table has. It has information about 10 different employees, their ID, their name, their manager ID, salary, designation, etc. Right? So that is fine. I already know what that is. This is a new table. This table does not exist in the database, right? I do not have a table by the name CT in my database, right? Because if I come out, if I do a select star from CTE, okay, this is going to throw an error telling that relation CT does not exist because CT is not a table that is present in the database. Okay, so what is exactly this CTE? This CTE is basically the your with clause itself. Okay, basically whatever name. So here I have given CT, you can give any name that you want. Okay, whatever this CT is basically holding the data that was returned from the previous iteration. Okay, when the first iteration got executed, this part of the query was never executed, right? So basically this was never called. So this will get called only in the going from the second iteration onwards, right? In the second iteration, this CT is going to have the output from the first iteration. Okay, so in other words, if I had to rewrite this query outside, okay, so I'll just try to explain this step by step. Okay, so my first iteration here, when I execute, I'm getting this one record. Okay, in my second iteration, if I had to rewrite this query, I can also write this query something like this. Okay, so I can just tell this one. Okay, I'll copy this. Okay, and I'll put it here. Okay, so this query here is basically same as this query here. Okay, what am I doing? I'm just fetching all. Basically I'm fetching, I have written this query, that is my base query, right? So this CT is going to have this result set. Okay, and from this result set, I'm joining the employee ID of this record, that is Asha, that is 7. Okay, and I'm joining and I'm checking that with this employee details table. Okay, so my employee details table is having all of this record, right? So this CT is going to have data for Asha only, that is this one. Okay, and I'm telling CT.employee ID, that is 7, right? CT Asha ka employee ID is 7. This 7 I'm trying to match it with employee.manager ID. E table is basically this all the table, and in this column, so 7 will try to match here. Okay, these two records will get matched and I should probably get this data, that is 5 and 6. Okay, so now when I execute this, you can see that in my second iteration, this is what gets returned. Okay, so this is what is happening in the second iteration. Okay, is it clear till now? Till now, I think you understand, right? First iteration, in the first iteration, only the data for Asha gets returned because this is my base query. In the second iteration, CT is going to have the data returned from the base query. Okay, and when I combine everything together and I run it, I'll get this 5 and 6. Okay, So this ct.employee ID is Asha's ID. Yes, correct. Okay. So this is my second iteration. When it goes to the third iteration, what happens is this CT is basically going to have the data from the second iteration. Okay, so this entire result set is going to be present in CT during the third iteration. Okay, so in other words, if I have to rewrite this query, okay, for the third iteration, okay, so I can just tell, maybe I'll just put it here. Okay, so first iteration, okay, that is this query. Okay, and then second iteration, okay, that is, okay, second iteration is this query here itself. Okay, then comes third iteration. Okay, so when I say iteration, it's basically third execution of the query. Okay, in the third iteration, again, what happens is SQL is only going to execute this. Okay, so I'll copy that and I'll put it here. Okay, but here the thing is, this CT is going to have the output from the second iteration. Okay, so the output of the second iteration is basically the result of this query, right? So what I can do is, instead of CT here, I can put that entire subquery here. Okay, and I'll move this to the right. Okay, so I'll move this to the right, and this entire thing is my CTE. Okay, so it's recursively happening. Okay, so I hope this is not too confusing, and maybe I'll just move this here. Okay, so this was my second iteration. Okay, and in my third iteration, that whole query from the second iteration will be used. Basically, the result set from the second iteration will be used. That will be stored in CT. In this case, CT is going to have 5 and 6. Okay, because this 5 and 6 was written for my second iteration, right? So when I executed this, it returned me this record 5 and 6, and this ct.employee ID will be 5 and 6. This 5 and 6 will now be matched with all the data in my employee details table, that is here. You will see if manager ID anywhere has 5 and 6. Okay, only these three records will match, because only these three records have 5. 6 is not present anywhere here. Okay, so now when I execute the third iteration, hopefully I should get these three records. Okay, so you can see that I'm getting these three records: Satya, Jia, and David, 2, 3, 4. Okay, so this is the third iteration. Okay, now when I come to the fourth iteration, okay, what happens is, again, this query gets executed. Okay, so I'll copy this. Okay, I'll paste it here. Okay, but the thing is, in this case, what is CTE now? Can anyone tell what is CTE here for the fourth iteration? Adam, your understanding is correct. Employees from the previous iteration becomes the new manager. These employee IDs will not match with manager ID. CT is what's on the screen now in the employees. Okay, perfect, right? So in this case, CT is basically the result that is returned from this query. So I can just copy this query here, okay, and I can put it here, okay. So I'll put it here, okay, and maybe I will move this to the right, okay, and let's say, okay, so the query has become too nested, okay, maybe too confusing, but I hope if you have followed from first, you will understand. Okay, so what happened was, this whole thing here is my result from the third iteration. So when I execute, I'm getting these three records. Okay, and here the employee ID that I'm getting is 2, 3, and 4. Okay, so this ct.employee ID will be 2, 3, and 4, and it's going to see if any of these employees are actually managers. Okay, how? It's going to try to compare these 2, 3, and 4 in the manager ID column from the employee details table. In the employee details table, it's going to see if manager ID anywhere has 2, 3, and 4. There is no 2, 3, and 4 present here, right? So that is the reason, when I execute this fourth iteration complete query, this should probably return me no records. Okay, so when I execute, it's going to return no record. That means the condition has failed, and that is when the recursion will come out. Okay, the execution will stop. Okay, so this is basically the whole flow of recursion that is happening. Okay, so your actual query is this, but internally what SQL is doing is, in the first execution, SQL executes this base query. In the second, again, it executes one more time. In the second execution, this is what gets executed. Okay, in the third iteration, this is what gets executed, and in the fourth iteration, this is what gets executed, until it will execute until there is no data found. Okay, so no data found is only in the third iteration, and that is when it will come out. Okay, is this clear? Did you get some understanding now? Okay, so now let's see, was anyone able to solve my problem, this particular problem? Okay, so Brent, are you sharing the solution? Okay, so let's copy Brent's solution. I'll see how many people were able to solve this problem. Okay, so this is a solution from Brent. Then I have a solution from Murali. Anyone else who was able to solve this problem? So I have got a solution from in Oracle. I'll tell you the syntax a little later, Rakesh. There is a slight difference in Oracle. Okay, Bhavesh has shared a query. So let me take 4 to 5 queries from someone. Uh, so Prashant has given a query here. Okay. So I think that's fine. So 4 people's query. Let's see whose query works fine. Okay. So Murli, Bhavesh, and Prashant. Okay. So what has Brent done? I need to find a way to beautify these queries. Okay. So let's do one thing. I'll just execute this. Okay. So already I'm getting the data. Okay. So Brent's query is fetching Asha and Asha's Michael and these three. But the only problem is Asha is not getting any manager name. Okay. So this is the only problem. So how did you miss the manager from Asha? Okay. So this query not right. Let's look at Murali's query. So Asha, and here I'm displaying varchar and level. Again, for Asha, the manager is not getting displayed, right? So this is also not correct. Let's look at Bhavesh. Okay. Bhavesh's query is giving an error. What is the error? Employee name does not exist. Okay, let's look at that later. Prashant's query has three. Okay, both are having error. Did anyone go through whose query was right? Anyone? She doesn't have one. Okay, no, Asha has a manager, right? If you look at the employee details table, so this is my employee details table. Can anyone tell who is the manager of Asha? Can anyone tell who is? Yeah, Shripad, right? So Asha's manager is employee ID 1. Employee ID 1 belongs to Shripad, right? So Asha's manager should be Shripad, right? So how can I solve this? So let's go back and take my query. Uh, this was my query, right? So I'll just copy this, okay, and I'll just say I'll put it here, okay. Now, if I execute this, I'm getting the data, okay, what I want, the all the employees under Asha. But now I only want 3 columns to display, and instead of manager ID, I want manager name. Okay. So first of all, in my second part of the query, if I wanted to display the manager name, okay, uh, I can say that this CTE is going to return uh, Asha. This is the employee ID, E dot manager ID. So this E table is basically going to return me all the managers, right? Okay, so let's try to better understand this. So this is Asha first, okay, this record here, and she's an employee. Then I take her employee ID 7 and I match it with the manager ID here. Okay, so but this is the employee ID. So this basically is, so this is the basically the manager, right? This whatever is holding in the CT is the manager. So in other words, if I just, okay, so maybe I will remove the level. Okay, I'll remove the level here. I don't need that for now. And here, if I just tell CTE dot what is the column name? Employee name, right? CTE dot employee name as manager. Okay, so here this should print me my manager, but since it's a union, even the about table also should have that column, right? But I don't have CT table here, so for now, let's say I'm just going to say none. Okay, just just to execute this query, and let's see now. Okay, and 4 columns. So 1, 2, 3, 4, and 1, 2, 3, 4. What is the error? Recursive query CT column 4 has type context. Okay, so type mismatch. I think this one I need to convert it into varchar. Okay, so let's execute this. Okay, so now I'm getting for Michael manager is Asha. Okay, and for Arvind manager is Asha. For Satya Ji and David the manager is Michael. That is fine. But I also need the manager for Asha, right? Can anyone tell what would be the hack? So basically in this query here, instead of printing none, I want to print the manager name Asha. So how can, sorry, manager of Asha. So how can I do that? How can I modify my base query to print the manager of Asha? Anyone? Another join condition, start with top. Uh, Something else. There is a concept in SQL you can use to easily find this. Anyone? Which we have already covered. How can I modify this base query to print the manager of Asha? Anyone? No, not lead lag, top level, etc. Self join, right? So Murali says self join, and that is what we have seen previously, right? Now what I need to do is I have this employee details table, right? So if I execute this employee details table, I get all of this information. So I'm taking the employee Asha. I want to find her manager. So basically I want to compare this record with this record here, right? So in this case, since I want to compare a record from a table with some other record from the same table, one of the concept that I can use is self join, right? So what I can just tell is I'll give an alias like E for this, and here I'll join the same table again. Okay, and so let's say this is employee, and let's say this is my manager. Okay, so yum. Okay, so maybe I'll just tell EMP and MNG manager. Okay, and here all these columns I was fetching from the employee table, so I'll just copy that. I'll put it here. I'll put it here. Okay, now I need to do the join. So how do I join? Okay, these two tables. So my employee table has employee Asha. Okay, so I want to take Asha's manager ID, right? So emp dot manager ID is equal to, so this manager ID is 1. I want to match this manager ID with here, right? Employee ID, right? So employee ID of this manager table. So manager dot employee ID. Okay. And then this manager table ka employee name will be my manager. So I can just go here and I can just tell, okay, I'll remove this. Okay. Manager table dot employee name as my manager. Okay, hopefully this should work. So in other words, if I just execute this query and I'm getting an error, so employee dot manager id, manager id, why am I getting error? Okay, so here it's not employee id, it is column name is id, right? Okay, now let me run this. I'm still getting error. Employee dot manager id. Okay, I think this is name, not employee name. Okay, now if I execute this, and column name ambiguous. Okay, so this is from my employee table. Okay, so now if I execute this, and now you can see that I'm getting Asha and her manager as Shripad, right? So now probably if I run this entire query, I should be able to get the manager of Asha as well. And I do not want to print the manager ID, so I can just remove that here. Okay, I'll remove that here. And if I execute my entire query, you can now see that very easily just by using a self join in my base query, I have returned the manager of Asha. Okay. So is this clear? Any confusion here? Is it clear? Anyone who is having confusion on recursion, on self join, this query is pretty interesting, right? We had a base query. Initially, you might think that base query just has to be a simple query. Of course, we can do so many things. Just that this base query should be able to execute on its own. Okay, so we just used a self join to fetch the data that we need, and then the recursive part of the query is working as usual. Okay, so the only major change is that you are selecting the names, but the recursion is the same. Yes, I'm only selecting the name. The recursion is the same. Okay, here I can add any number of columns that I want. Okay, the column list does not matter for recursion. Recursion matters based on this join here that you have mentioned, the CT. Okay. So the flow of recursion is the same. I just added some more columns to make it more meaningful. There is no explicit terminal. So I have not. So it's not mandatory that you need to provide explicitly a termination condition. Termination condition can be even a join condition. Okay. So here the recursion will happen until it finds a manager for a particular employee, right? Or basically it finds a employee for a particular manager. As soon as it finds a manager or a employee who does not have any managers, the query will stop executing because it does not find any record. Okay. So when I say termination condition, it does not always have to be a where condition with a filter condition. Even a join, as soon as your processing is completed, the recursion will come out. Okay. So but you should make sure that this join condition at some stage is going to return no records. Okay. Only then you can treat it like a termination condition. Okay. So same number of columns, right? Yes, you need to have same number of columns because that is the rule of union, right? Both the queries needs to have same columns and same data type as well. Base query and the recursion query needs to be the same. No, base query and recursive query is different, right? This is my base query. The recursive part of the query is this one, right? They are not same. Yes, same number of columns. Yes, same number of columns and same data type. What happens if you use, in this particular case, nothing will happen, no issues. Okay. So if I put union all also, it works the fine. What is union? What is the difference between union and union all? Union all will return all the data. Union will return the distinct data, right? In this case, by default, I had distinct data only. So that is why union or union all does not matter. Okay. In some cases, if the data is duplicated, then it might matter. Okay. Okay. So this is fine. Now I have one more question for you. Now, because I hope I have slowly explained you this concept. The next problem you should be able to solve. Okay. So I'm going to give you, let's say, 3 minutes to solve the next problem. Let's see who can solve it. Okay. Uh, the problem is, okay. So this is my problem. Okay. So can anyone solve this problem? Let's see how many people can solve this problem. Okay. Command does not work. Okay, so I'll paste it here. Okay, so I need you to. So previously, what we did was we took an employee and in other words, we took a manager and we saw all the employees under her. Now I want you to do the reversal of that. That is, find the hierarchy of managers for a given employee David. So you take an employee David and see who are the managers above him. Okay, who is manager of David, and if that manager has another manager, who is that manager, and so on and so forth. Okay, so can anyone write this query? Okay, so I'm going to provide the same query to everyone. Okay, so I'll share this query here. Okay, so okay, so Suraya tells replace Asha with David. So let's see if that works. Okay, so I'll just, okay, so Suraya tells replace Asha with David. Do you think this will work? How many people think this will work and how many people think will not work? Join also should change. Okay. Anyone here who thinks this will work, or Prashant is telling join should change? Prashant, can you tell what join should change and why? Or anyone, if they can solve this problem, well and good, just share with me. It will work. Okay, so I'll execute this. It's not throwing an error, but it's only returning David, right? But if I go back to my employee details table, okay, so let's say I do select star from this table. Okay. Here you can see that this is David, right? So David is this guy. So I want to find the hierarchy of managers. So David's manager is number 5. Number 5 is basically Michael. Michael's manager is number 7. Number 7 is Asha. Asha's manager is Shripad, right? Number 1, that is Shripad. So basically I should get David, under David, my Michael, under Michael Asha, under Asha Shripad. So there should be four records, right? But this query here is only returning me David. That's it. Okay. So how can you modify this query? Anyone? Okay. Uh, Maybe I'll just wait another 1 minute. Let's see anyone can solve it, or else I'll solve it. Add another recursion. Okay, Abby. Left outer join. Okay. Any other? Like, what do you guys think? Prashant, what did you say? CTE should have manager ID. Okay, so Prashant is telling that we need to join CTE using the CTE ka manager ID. Okay, fine. What about others? So someone is telling left join, someone is telling right join. Okay, CTE manager ID equal to employee ID. Okay, so Adam and Prashant are telling the same thing. That is what Adam has mentioned here. Okay, so Adam, can you explain this? Or Prashant, can you explain why this kind of join? Why are you reversing the join? Do you know why you have to reverse the join? Can you explain that? We are going bottom up approach. Okay, fine. Okay. So I think Adam and David's manager is a new employee. David's manager is a new employee. Okay, right. So I think Adam and Prashant are correct. Okay. We had to. Okay. So let's try to understand, okay, our requirement. Our requirement is we need to find hierarchy of managers for the given employee David. Okay, now when I run my base query, I will get one record for David. Okay, so I have got David and his manager, uh, Michael, right? Now what I want to find is David's manager is Michael. I need to take this manager, okay, basically the Michael, okay, and then I need to search for Michael. Okay, so David, this one. Okay, so I need to take I need to find the manager, right? So I need to take the manager ID of David. Okay, and I need to compare. So this is 5, and 1 minute. So I have David here. Okay, so manager for a given employee, David. Hierarchy of managers for a given employee. So hierarchy of managers, right? So I take David, okay, and I take his manager ID, that is 5, okay, and I search for this manager ID in the employee ID column, okay, and I'll find it here. So this basically Michael will get matched, okay, and then this Michael's manager is 7. So I take this 7 and I try to find that 7 in the ID column here. Okay. Then I'll find Asha. So Asha's manager is 1. I take this 1 and I try to compare it with here. Okay. So it's kind of reverse of what we did previously. Okay. So here I have got David, and in the next recursive part of the query, my CT is going to have the record for David. But for David, I need to take his manager ID. So David's manager ID is what I need to take. So I'll just tell cte.manager ID. Okay, and this manager ID I need to compare in the ID column of my entire employee details table. That is, I need to make here like ID. Okay, and then recursively the same thing will continue. Hopefully I will get the output that I want. So now if I execute this, cte.manager ID. Okay, so okay, I do not have a manager ID here. So let me add a manager ID column here. Okay, so here let's add that column. I'll just tell emp dot manager id. Okay. And I need to add that column here as well. That is e dot manager id. Okay. So now if I execute this, now I'm getting all the result basically. So here I can just tell David's manager is Michael. Okay. Michael's manager is David. Asha's manager. This looks wrong. Okay, so basically I need this one I need to remove. Okay, so this was used for a previous join. This is not the way to do it. So I'll remove this manager. Okay. To be frank, I don't need this self join here. Okay. So I get my employee ID, I get the employee name, and then I get his manager ID. Okay. So now let me run this. So here I can see that I have got David. Then David's manager is Michael. Michael's manager is Asha. Asha's manager is Shripal. Okay. So this is how it is done. Okay. I hope this is clear. Now, can anyone, instead of printing manager ID, can anyone modify this query to print the manager name? Again, similar to like what we did previously, right? I think only the join we need to change, right? So maybe I will try to do it myself. Okay. So here again, I will join with the same table. Okay. So, but before that, let me add a manager name here. So I have my employee manager ID, right? And then, so this is my manager ID. Manager ID is here. So here, if I just say e dot name, okay, not e dot name. So this is David's manager is Michael, right? So that is this one. Okay, so I can just tell CTE dot name, CTE dot employee name as manager. Okay, and let me just copy the same thing here. I need the manager ID first of all. So here, and I'll put it here. Okay, and let's say for now I'll make it like none. Okay, and maybe I will comment out this one and let's see if this works. Column has 4. Okay, so this is varchar. Okay, so here David none, Shripad. Okay, so can anyone solve this? Let's see who can solve this. Okay, so first of all, let me show you the actual query that I have, and then let's try to solve it. Okay, so first of all, I'll remove this and I'll execute this. Okay, so this is the result for my this particular query. Okay, that is find a hierarchy of managers under David. So here I can just tell David, Michael, Asha, and Shripal. Okay, so this one I have got. Now, what I want to do is, what do I want? So, no, David's manager is Michael, right? So, let's go back to the employee details table. So, David's manager is Michael, right? Okay, so David's manager is Michael. So here instead of manager ID, I want to display Michael. For Michael, I want to display Asha. For Asha, I want to display Shripad. But Shripad does not have any manager, so it can be null. Okay. So can anyone modify this query to return the manager name? Anyone here? I'll share the query with you. Let's see who can uh, return me the final output. Okay. Till then, I'll just try to solve it here. So we write the above query to display the employee name and manager. Okay, that's it, just 2 columns. Okay, so let's see how I can do that. Okay, so I'm just going to copy this query here and I'll paste it here. Okay, and so let's go one by one. Okay, first let's start with here. Okay, so in my recursive part of the query, all the data I'm taking from the employee name. Okay, and then this manager ID is basically 5. Okay, this is my 5 is my manager ID that I have taken, and then here, let's say if I just say CTE dot name, okay, as manager name. Okay, and here let's say I'll just put none, and I'll just convert this to varchar as manager name. Okay, let's see if this works. I'm getting an error. CTE dot Okay, the column name is ct.employee name. And now let me run this. So now here it's kind of not doing how I want it to do, right? So I want to display, okay. So this is not the right way of doing it. I think here also I need to do a self join. Okay. So, okay, this is not the right way of doing it because here the here the hierarchy is happening reverse. So even this data is getting actually returned as reverse, right? So anyone solve this problem? So, okay, so Prashant has, I think, shared the problem. So let me copy Prashant's solution and see if that works. Okay, or else I think we can use self-join to solve it. So I'll just run this. ID is ambiguous. Mm. You did not use recursion, is it? Uh, okay, so let's try to solve this here itself. Okay, okay, so this query is returning me David, and here I want to display Michael, right? So what I'll do is let's join with another table, again the same table, okay? And let's say maybe I will call it like, I don't know, maybe the M table, okay? And maybe I'll join this table at the end. Okay. And here I want to say is, so I have got this manager ID for David. So this manager ID, I need to search it in the employee ID table. So I'll just tell e dot manager ID equal to m dot ID. Okay. And then here, if I just tell m dot name, this should be my manager name, hopefully. Okay. So I think that's all. Now let me just copy and put it here. And let's say for now, I'll just keep it like none. This is varchar. And let's see if this works. So the data has changed. So, okay, the data is fine, but it's not returning the number of records. Okay. So why is it not returning number of records? So this is returning me one record. Okay. And then here, this CTE is returning me Asha and Shripad here. This Shripad needs to move to the next line. Okay. So actually all these three records are fine, but I need to have another record here for Shripad, which should basically print as null, right? But that is not happening. The last recursion is not happening. Okay. Okay. So I think uh, let's do one thing. I'm not going to be solving this problem here. Okay. Is anyone else able to solve this? Okay. I think I'm a little tired, so maybe not getting the idea, but maybe you guys can get the idea here and then you can solve it, or else I'll try to give you the solution in the next class for this. Okay. So I'll just keep this query as it is. I'll just mention here this query needs to be modified. Okay. Okay, so let's see who can solve. Okay, Prashant has given a solution. Let me copy Prashant's solution. Let's see if solution is correct. Okay. So Prashant, is this the entire query or is this something that I need to put inside the recursive part or the base query? Is it? Okay, okay. So let's, okay. So I'll copy this one, remove this. So I need to put this inside the base query is what he's telling. So I'll just copy this entire thing and I'll put it here and I'll copy this entire base query and I'll put it here. Okay. So what are you doing? You have done a self join here, employee ID, employee name, and manager name. What about the recursive part of the query, Prashant? Do you have it? So here you have 1, 2, 3, and 4 columns. So 1, 2, 3. So you do not have the manager ID. If you do not have manager, you need to have a manager ID here. So otherwise your recursive part won't work, right? Because we are using manager ID for joining. So I'll add a manager ID here. Then you added a manager, and okay, then the level. So maybe I'll comment out the level, and maybe I'll remove this self join that I added, and here let's say I'm just going to say maybe null for now. Okay, none varchar, and let's see if this works. Error. What is yum? Yum dot name. This is throwing an error. Did your base query work? Okay, your base query worked, but this is not correct, right? Your base query is fetching Michael as the employee. Ideally, we want to fetch David as the employee. So this is like doing the other way around. Okay. Okay, fine. So I think I'm going to stop the class here. I'm actually, maybe my mind is tired, so I'm not able to find a solution for this. I'll try to find a solution and give it to you in the next class. If anyone else has a solution, you share it with me. Brent just shared a query. Let me use Brent's query. Let's see if it works. Okay. This is a query from Brent. Let's execute this. David Michael. Okay, awesome. So Brent has actually solved the problem. So you can see David's manager is Michael. Michael's manager is Asha. Asha's manager is Shripad, and Shripad does not have any manager. Okay. So let's look at how Brent has solved this problem. Okay. So let's move this to the right. It's here. Join and where class union all and this one and this. It's left join here, and then okay, so maybe when you're printing, I'll just print employee ID, employee name, and manager name, just the three columns that I want. And let's execute this. So this is the correct output. And how did you do this? So you're do let's look at the recursive part of the query first. So I think this was already there. Okay. Additionally, you added a left join. Oh, correct. So previous query that I had, where was that? Yeah. So this was the query, right? So previous query that I had, it was fetching one data less. And what Brent did was he just put a left join here. And this way, I think you will get the data for Shripad. It is null. Okay. And then here, none. This one I can easily do by adding a self join, right? So I can just do this. Okay. So join, and I'll just tell yum manager. Okay. And then how did you join this? So David, his manager ID is this one. So employee dot manager ID equal to mng dot id, and you just fetched mng dot name as manager name. So did this work, Michael? So I think okay, so this is exactly what even Brent got. Okay, and this is what he did. Brent, fantastic solution. So just by looking at your solution, I got the idea. Okay, so this is actually good work. You used a self join here. You realize that one of the record was missing here, and that is why you used the self join. So we got data for even those employees who did not have any manager, and Shripad was that person, right? And then here I think it was simple. You just did a self join here, right? So we have got the solution thanks to Brent, but good one. Okay. Okay. So I think I'm going to end the class here. I have four more minutes. If you have any questions, you can ask me. If not, I just want to mention that in the next week will be the last week of this course. Okay. We officially we have three more three more classes, right? So today is 18 session 18, but I missed one of the session because I was unwell. So that session that I missed is going to be scheduled for next week. Next week, yes. So three sessions that are scheduled as per my initial schedule, and I'm going to conduct one more session that will be an extra session for Q&A, any questions that I have not answered or anything that you have doubt on, you can ask me, but you need to ask me beforehand. Okay, so I'll collect the questions and I'll try to answer them in the session. Okay. um, and then in the next three sessions that I have, right, I'm going to start with user defined functions and stored procedures. So we'll try to create some sample stored procedures and create some user defined functions. I'll try to explain that. Once we are done with that, then we'll move on to our project. I'm going to take a data set from, I think, Kaggle or from GitHub. Okay, and we'll try to analyze that data set, and then we'll try to solve some problems using that data set. Okay, so that's the plan for next week, which is the last week of the course. Okay, I hope so far you have benefited from this class. You have learned SQL, but as I told you in the beginning, when you are learning something, if you can refer to multiple sources, that is actually very effective. For me, it is very effective. I am sure it's going to be effective for you also. Okay, so data with Danny, that I think Tim referred, and then the book also that Tim referred, and any other resources for learning SQL, if you have, you can definitely share. I referred the SQL course on learnsql.com, the free course, that one you can do. But anything else that you guys have, you guys you guys think that SQL, you guys think that you have a good SQL resource, you can definitely share it. Okay, even if it's of some other YouTuber or something, does not matter. If it's a good resource, you can share it. We are all here to learn. So I got a solution from Brent today, and I have learned so many things from my students itself. So uh, keep sharing any good resources. Even after the course is done, the Telegram group will be active. Okay, if you want, of course. Okay, if you want to leave, you can leave the group, no problem. Okay, but any good resources like data with Danny, the SQL course on Learn SQL, the book that Tim suggested, and any other resources, you are welcome to share. So let's help each other to learn. Okay, when you will be covering inbuilt functions. Okay, so in the next week, I'll try to give you a list of all the inbuilt, not all, the most important inbuilt functions. Okay, so I'll try to give it next week. I'll thank you. Okay, that's good. Yeah, thank you. Can you please provide data sets so that we can download? And I always provide the data set, right, Josna? Like after every session, if you go to Lighthall, you will see a folder with data sets. All the data sets are there, but there are only some data sets. But if you go to the notes file, in each class, which the queries to solve a particular query, if I have used a new data set, I have given it in the notes file. Okay. For the upcoming project, I'll give it maybe next week. Okay. September 9th, 5 a.m. I thought that is first session. September 9th. September 9th. Today is not the first session. We are just ending next week. Okay. Okay, so I think that's all for today's class. Okay. So anyone else has any questions, you ask me, or I can drop now. Okay, so I think that's all. Let me just copy all of these notes into the notes file. 1 minute. So today's session 18. So this is my notes and okay, fine. So I think that's all. Thank you everyone for joining. I'll see you all next week and have a good weekend. Stop share.